workshop on artificial intelligence, innovations in fuzzy optimization, cyber triggers.
Recording in progress.
This is the first session of the last day, and in this session, our resource person is Mr. Ayush Upadhyay from USA. I welcome you, sir, to this international workshop, and I invite Mr. Tarun for brief introduction of Mr. Ayush Upadhyay.
Good morning to all. It is my pleasure to introduce Mr. Ayush Upadhyay, a machine learning engineer and researcher from Texas, USA, with strong expertise in scalable ML infrastructure, distributed system, and advanced AI techniques, including 3D computer vision, generative AI, and reinforcement learning. Ayush is currently pursuing his MS in Computer Science at Texas A&M University, where his research focuses on 3D scene reconstruction, SLAM optimization, and vision transforms. He has practical experience building fault-tolerant microservices and high-throughput ML system, having worked at LinkedIn and Illumio. He has multiple publications in AI and ML domain and actively work on projects involving deep RL, genetic algorithms, and secure distributive ML systems. Ayush completed his BTech in computer science and engineering with top honors and has a strong proficiency in Python, Golang, Rust, and system tools like Kubernetes and Docker. Today, he will speak on the topic LLM determinism at scale for cybersecurity. Please join me in welcoming Mr. Ayush Upadhyay. Over to you, Mr. Ayush Upadhyay.
Thank you, Tarun. Thank you for such a kind introduction. Hi, everyone. Thanks for having me here. Let me share my screen quickly. Okay. I hope everyone can see this. I see it on the screen. Okay. Hello. I'm Ayush, and I wanted to talk to you about a case study almost of the work that I've been doing with LLMs and cybersecurity. So, lucky me, the symposium turned out to be a great opportunity. What you see in front of you is something that a cybersecurity analyst sees day to day. This is a dashboard of all of your network flow data. It shows you what kind of services your network infrastructure is talking to, which IPs are sending traffic to your network infrastructure, and so on and so forth. But at 8 a.m. in the morning, if this is you, this is how you look like as a cybersecurity analyst because there is so much data, there is so much volume that you have to process through in this field, and not everything is a clear signal, right? So since 2023, we have LLMs in the picture, and the landscape has evolved quite a bit. And now we are finally at a stage where you can send a lot of data to these LLMs and basically ask it a question saying, okay, this is all the network data I have in the system. Tell me what exactly is going wrong. So this is what want to talk to you about, just the scale agnosticity part of LLM systems. How do you build systems, especially in the cybersecurity realm, that can handle a really high volume of input? So, like, this is a very expert panel that we have in this conference. So, you guys realize that all of the LLMs have very limited token windows. All of your famous models right now, ChatGPT, are sitting at around 200 to 300,000 tokens. But all of the data, network data that comes into our LLM, if we decide to use it for it, are exceeding well over 10 to 20 million tokens per day. So, how do you ensure that LLM systems can actually produce a good cybersecurity reasoning? Is what I want to talk to you about. And I will present it as a case study on how I have done it in the past, and hopefully, we get some insights from there. So, as I was saying before, you might think that the way we can achieve a solution to this problem is just take a lot of network insights, take a lot of cybersecurity insights, send it to an LLM with a prompt saying, okay, this is all of my network data. Please give me some analysis. Please give me a cybersecurity analysis of it, and you will get a threat intelligence report. That's not how it works at all. Problem is, as I said before, um, these LLMs have really limited context windows. So, for example, ChatGPT right now, the GPT-5 model that came out, is sitting at around 272,000-ish tokens, right? So as soon as the input exceeds this 272,000 context window, it will start hallucinating. And I'm very sure like people who are using ChatGPT day for day to day, not even in the cybersecurity context, have faced this. So for example, if you try to talk to ChatGPT for really long, it starts to hallucinate. It starts to forget what you said earlier, right? Now, especially in the cybersecurity realm, the authenticity and the trustability of the information that the LLM is giving you back is very important. So we come to the next problem, which is that since the model has started hallucinating because we have exceeded the context window, we lose reproducibility. So to give you an example, if I take 1 week worth of network data or cybersecurity data and feed it to an LLM 5 different times, since these models tend to hallucinate a lot, you will get 5 different responses every single time. So for one time, it will say, okay, IP XYZ is malicious, right? For the next time, it will say, okay, port 445 is malicious. And then the next time, it will say there is a MySQL database virtual box that is sending malicious traffic, right? You as a cybersecurity analyst will be like, okay, this is useless to me, right? Because I want some alerts, I want some trustable information that I can use and take action on. LLMs just don't work this way. So coming back to this architecture that I showed you, this just does not work in the real world. Okay, so I will come back to this. This is the case study thing that I was telling you about. So to introduce the problem again, the way I used this was to analyze a lot of network flow data. And what network flow data means is just that how many bytes, how many flows are going from machine A to machine B, or port A to port B, or IP A to IP B. That kind of data is called network flow data. A lot of famous companies you know in the world are using this kind of data to analyze security patterns. Googles of the world use this kind of data. VMware, a bunch of companies, Cisco uses this kind of data to analyze security. That is network flow data. And what I've done in the past is try to design a system that can take very large volumes of this data, multiple petabytes worth of data every day, analyze it, and produce what is called a threat analysis. So, threat hunter is a very specific cybersecurity person whose response. Sorry, someone is on mute. Yes. One second. Yeah, coming back to this. So, yeah, this is a threat hunter persona. And as I was saying, I will come back to the high level to explain it to you, but this is how the architecture looks like. So if you remember this very easy worldview of things, it's usually not helpful at all and fails at the very end. So the way we achieved a good threat analysis was 3 large steps. The first is pruning, the second is clustering, and the third one is the actual analysis. So I'll walk you through each of these and why we do using this diagram here. So most of it is not relevant to everyone here, but I want you guys to focus on this orange boxes here. The one that says data retrieval agent and then it says statistical pruning and all of that, right? So all of these yellow boxes, starting there is what we used to ensure that we can take a lot of volume of data and feed it into these systems and still produce a reliable, reproducible, and accurate result without hallucination, even when we are using different LLMs. So, few specific components that I want you guys to look at before we dive deeper into it is that we are using multiple different LLMs at multiple different stages, right? So, on the bottom right here, let me see if I can use a pointer or something.
उससे माइक आना करने में कुछ कुछ पड़ जाते हैं, ठीक रहता।
Okay, so I think someone's on unmute again. Mr. Ravi.
Continue, sir. Continue.
Okay. So yeah, coming back to it. Yeah, if you notice, we're using three separate LLMs, and it's not just one LLM that we're feeding a lot of data into. So on the bottom right, you see there is a reasoning model, right? So if you guys remember, a few months ago, ChatGPT used to have this model called O3. They asked you to choose one of the models. You could either choose GPT-4o or you could choose GPT-O3. O3 models are the one that are called reasoning models. So what that just means is that it takes a little longer to reason on a specific thought chain. So you can use these models for complex analysis. You can use these models for mathematical analysis, coding, etc., etc. So yeah, at the very end, we are using a reasoning model. Before that, here is if you see inexpensive model 404 mini. This is just your GPT 4.0, and now in the present day and age, you as a machine learning engineer or you as a machine learning specialist need to understand the power of each model, right? So there's 1,000 different models that are coming out right now. OpenAI from the ChatGPT company is producing a bunch. There's a company called Anthropic that is producing a lot of models. And then there's a lot of open source projects right now. Facebook is releasing a bunch of different things. So you as a machine learning specialist need to understand what model provides what kind of functionalities, right? So these reasoning models, although they are really powerful at actually reasoning through different complicated things, it is also very expensive. So for 1 million tokens that it can produce, it is charging us around $10 to $15. And if you imagine um, a large scale system that is trying to use GPT-o3 for everything, you will run into a bill which is like worth a few crores at the end of every month, right? So that is not practical at all. Which is why you need some inexpensive models, right? So 4 mini kinds of models. These are very inexpensive models. These are very fast output producing models. There are metrics like time to first token. So these models have really small time to first tokens, meaning if you ask it a question, it will immediately start giving you a response, right? And then the other model here is this text embedding 3 large model, which is just a embedding model and not bog you guys down with the details there. But this is not a language model, meaning you cannot really talk to it. What it does is it gives you a text, mathematical representation, a vector almost, for any given input. So if you imagine that a vector for the word king will be very close to a vector for the word emperor, right? Because they are very close in terms of meaning. So that is what an embedding model does. Now, coming back to it, this is the high level. The way we achieved this scale agnosticity in this case was we did two interesting things before we fed any information to an LLM, which is pruning and clustering. So pruning just means taking a bunch of resources, we're taking a bunch of these network data records and just deciding what is a record that is of high value versus what is not. And you guys are a mathematical audience, so I'm taking the liberty to use these words here, but we remember Shannon entropy like of things, right? Negative log of P of X. So what you can just do is just basically assign the entropy score to each record that is coming in. And when you use metrics like Shannon entropy, what it will give you is it basically tells you how much surprise does each record have. So, for example, in a record, if I see that between yesterday and today, the flow counts change from 1,000 to 1,500, that has little information. But if it jumped from 1,000 to 100,000, that has a lot of entropy, right? Because this is a big jump. So with pruning, what we just do is assign these entropy scores to each of the records that are coming in. For example, if there are 50,000 records, we assign the score to each one of them. And we just take as many as we can fit. So for example, if GPT-o3 has 200,000 token limit, then we can take, I don't know, 10,000 of these 50,000 records, assuming that we just take the highest entropy records out of those. Perfect. Now, once you're done pruning, the next step is clustering these records. So, clustering, for those of you who do not know this, there are a bunch of traditional machine learning techniques that are non LLM in nature. For example, clustering, right? There is a bunch of different clustering algorithms that you can use in this case. There's K means clustering, there is DB scan clustering. What I used was something called a hierarchical DB scan clustering. But in essence, what it's trying to do is it is trying to form very large semantic groups in the data you have. So, to give you an example, for example, there's an IP, right? There's an IP that is talking to a malicious location in China, for example. And then the same IP is also sending a lot of traffic to a malicious MySQL database. And then the same IP is also present in a malicious IP database that some company produced, right? So these are a bunch of different information that is centered around that specific IP. That is what is called a cluster, right? So what you're trying to do is finding such groups in all of the data you have. Now, when you have these clusters formed, and then you have ensured that you have pruned out or removed all of the non-important records from before, now you are in a position that even if you had like 15 or 20 million tokens worth of input, or 50,000 to 100,000 different data records, now you just have the highest quality 10,000 to 20,000. And now these 10,000 and 20,000 can actually fit into an LLM window, right? So this reasoning model idea at the end. So now that you are well within the limits of a LLM, for example, this O3 model, now you can just take these high quality records, give it to the LLM, and just ask it, okay, here are all of the high quality records that I have from a security analysis. Can you do some threat analysis on my behalf? And these are the clusters you should look at. These are the high quality records you should look at. This is how you create the prompt, basically. Once you do that, now the power of LLMs shine, and they can look at all of these different data and then produce a really high quality input. So, um, yeah, what do you get out of all of this is just now whatever is the volume of the data that is going into these LLMs, the LLMs are agnostic to it, meaning I can have 1,000 tokens worth of input, 100,000 tokens worth of input, or 100 million tokens worth of input, and I'll still be able to process all of them, right? And the next step is reproducibility. So now, since 80 to 90% of the system is completely deterministic, meaning we're using traditional ML and not LLMs, we can be sure that every single time you give the LLM the same data as before, the analysis it will do will be the same, right? Because most of the things are completely deterministic. And then the last part is trust and actionability, right? So as a cybersecurity analyst or somebody who's responsible for the cybersecurity of the company, now you can trust the system finally because it's not hallucinating, it's producing the same results time and time again. And you can trust the system as maybe a junior threat analyst and actually take good actions and in all sincerity save the world because all of our lives are on the internet now. Our payment details are on the internet now. Credit cards, debit cards, family history, all of that, right? So we need these people to help us out and to build systems for them that they can trust is hyper important. Awesome. So that was it. I'll open it for any questions, any feedback you guys might have. Stop sharing as well. Any questions, anyone?
Hi, Ayush. That was a very interesting presentation. I do have a quick question. When you were talking about clustering and the different algorithm like DB scan and stuff, how did you decide which algorithm to move forward with? What was that analysis like on your end? I would like to know more about
That's an awesome question, Manasat. I'll frame it according to your background. Are you an engineer as well?
Yeah, I am an engineer, but I'm in product now, but would love to know the caveats.
Okay, awesome. Yeah, okay. The reason why I asked is from an engineering standpoint, the way it works is all of your security data is non spherical in nature, meaning you don't have defined centroids. So the example I gave you, right? For example, there's an IP that is talking to XYZ location. There's an IP that is also interacting with a malicious port, etc., etc. You might think of it like a sphere, meaning there's an IP that is at the center of all of these records, and then this IP talks to all of these records, etc., etc. And this forms a spherical cluster in nature, right? So what you need to decide, like the factors that go into deciding the clustering algorithm, is what kind of data you have, right? So whether you have spherical clusters or not, whether you can have clusters that are in different density shapes or not, and then you choose the apt algorithm for it. So I used a very rudimentary example, but in our case, in security analysis case, most of these clusters are not spherical, which is why most of the algorithms like k-means that have a defined centroid are ruled out completely. And that's how you decide which algorithm to use. And we went with HDB scan in this case.
So, sir, have you share your screen?
Sure. I can share.
PPT is not visible right now.
Yeah, I just ended. I can share it again. Sure.
All right.
Yep. Ayush, Aniket this side. Can I ask the question if the previous answer is over?
Of course, go ahead.
So I just wanted to ask a very crucial part of tech world is that we want a very reliable system, right? With AI getting inside the cyber security systems, and because cyber security is such an important part of the whole deployment and the product process, right? How reliable is it? If it is a very reliable process, is it easily attained or easily achieved by many of the startups or let's say very small companies, or is it a very robust system that we have to pay a lot of money for? So it's just for the reliability of the cybersecurity process, right? So how easily it is attained?
That's an awesome question, Ankit. And unfortunately, it's not easy to build reliable AI at all at this present moment, which is why around you, you're seeing the AI hype kind of getting stagnated right now. In our case, the way we ensure that the system is reliable is the entire architecture I showed you. But then there's a few other things that you can do on top of it. There's a very popular word in the LLM ecosystem called evals. These evals systems, what they do is, again, I'm kind of assuming that you're from an engineering background as well. But if you remember, there are things like regression testing, right? So you basically see how far your code is going from a baseline, right? Evals are kind of a similar thing, but for LLMs. So what you do is you basically build systems that constantly keep checking whether or not your LLM is hallucinating or not, whether or not it's still giving you desired output or not, right? So you introduce a bunch of checks and whistles around this entire system, and then you fire alerts accordingly. You treat it the same way as you treat any other microservice that you build, with alerts and with dashboards and with proper on-call systems. But at the end of the day, these are just word producing machines and really hard to keep them reliable. But with these tricks, we eval like systems in place, you can build pretty reliable systems now. Hope that answered your question.
Yeah. I use you say lightweight LLM.
Mhm.
What does it mean lightweight?
Okay,
They
so
choosing the weights or something else.
yeah. Okay, so Dr. Mish, there's two different categories of models right now. One are called SLMs, small language models, and one are called large language models, right? And the way you decide small and large is still largely dependent on the number of weights that a model has. So, for example, in GPT-5's case, the number is around 1 trillion. It has around 1 trillion weights that are associated with it. Whereas in the case of some SLMs, they are sitting at around 9 billion, 3 billion, a few million parameters, right? 600, 700 million parameters. So there's a few different things that happen. SLMs can be used for deploying on edge. So, for example, in your mobile phones right now, your iPhones and Androids of the world, all of your voice agents right now, the Siri, the Bixby assistant, all of them are powered by SLMs, meaning they are 600 to 700 million parameter models that are really small to run, and they don't really need large amounts of compute to run. which is why they can fit on your mobile phone. But the large language models like GPT-5, which is sitting at 1 trillion, they run in data centers in USA or Australia or someplace, and then you use internet to access them basically because they need a lot of power, they need a lot of compute.
I use one more thing. If we talk about ML or DL algorithms, so and if we deal with these LLM models, so
Mhm.
which algorithms are more suitable to these LLM models?
Right. So these LLMs are built on top of artificial neural networks, and more recently, they are built on a specific architecture of artificial neural networks called transformers. I suggest that anyone who's interested in this field, you should go read the first Transformers paper. It's by a fellow Indian, Ashish Vaswani. It's 2018, so if you just go Google Transformers, you'll find it. But as I said, like deep learning right now, at least in this large model ecosystem, is mostly artificial neural networks. There's a few techniques here and there around it, but the base architecture has not changed. Early research in machine learning was around things like convolutional neural nets, LSTMs, recurrent neural networks, those sorts of things. But after transformers, it has just been the same architecture, slightly tweaked. So every LLM you see, like Llama from Facebook AI, Claude from Anthropic, ChatGPT from OpenAI, all of them are transformer models.
But recently we are talking about XAI, explainable AI, and
Mhm,
agentic AI.
mhm.
So, if we integrate these algorithms, which earlier we have studied, will it work, or we have to modify something more?
Right. So explainable AI specifically, and then the other things are mostly paradigms. Agentic AI is also a paradigm. So, agentic AI just means when you're trying to use multiple different agents for a specific sequence of operations. So, the architecture that I just talked to you about is also agentic in nature, but the underlying agent is still using the same model. As far as explainable AI goes, again, as I said, like explainable AI, and we had a very awesome talk yesterday about it. It's centered around this paradigm that we need to understand these models as much as we can and the things that these models are doing. Unfortunately, with LLMs, that kind of goes out of the window, and people are doing a lot of active research. And if there is a young person in the audience, I would really encourage you to look into this kind of an area. But with LLMs, these models are largely black box today. We don't have shape or line like models that can be directly applied to large language models, but very active area of research on how you can understand how these LLMs are behaving. So today it's still an unknown, but yeah, hopefully in due time.
Thank you, Ayush, for a nice lecture, and you told how LLM determination at the scale of for cybersecurity. That means that we have to deal with these LLMs, but in the perspective of cybersecurity, we have to see the security must remain inconsistent model, otherwise it will create a problem. So thank you. Now I invite
Thank
Ashish
you.
for formal vote of thanks.
Thank you, sir. It is my privilege to extend a sincere vote of thanks to Mr. Ayush Upadhyay for his insightful and technically rich talk on LLM determinism at scale for cybersecurity. His clear exposition of the challenges in handling large-scale security data, the pitfalls of noisy summarization, and the practical techniques such as evidence grounded prompts, structured extraction, and iterative reasoning that enable dependable LLM. Now we will be 11 a.m.
Any one of the participants wants to give your his or her feedback, then they are welcome. Yeah, if anyone wants something new or anything else, you are welcome. बोलो किसी को कुछ कहना है तो हम्म, या अगर किसी के पास कोई नई जानकारी है सम न्यू इंफॉर्मेशन आई इनवाइट डॉक्टर संदीप फॉर कंक्लूडिंग रिमार्क्स
मैं मैं कुछ बोल Hello, good morning to everyone. First of all, I मैं प्रणाम करना चाहता हूं अपने गुरु पुंज को। आप लोग जो कहते हैं कि ये हमारे गाइड हैं, टीचर हैं, वो अलग-अलग नाम है, लेकिन वो गुरु पुंज है। और गुरु को क्यों ज्यादा महत्व दिया गया है? क्योंकि साधक और साध्य के बीच जो साधना का माध्यम है, उसके रास्ते को वो प्योरीफाई करके बताता है। एक वर्ड आता है इसमें, जैसे कहते हैं गुरु सबसे ऊपर है, गुरुर् ब्रह्मा गुरुर् विष्णु गुरुर्देवो महेश्वरा। तो जो तीन हम गुरु ब्रह्मा की बात करते हैं, वो जनक है, पैदा करता है। तो गुरु हमारे माइंडसेट में या सेट्स ऑफ माइंड में क्रिएशन करता है, चाहे इन फॉर्म ऑफ इंफॉर्मेशन या क्वेश्चन या इंस्पिरेशन। फिर जो विष्णु का स्वरूप दिया गया है, वो उसकी जो है पालन पोषण करता है। जो आपको प्रॉब्लम आती है वो गाइड भी करता है, इसमें ये कमी है, इसको हम रेक्टिफाई करते हैं। और ड्यूरिंग दिस पैसेज जो हमारे अंदर विकार पैदा होता है, उसको वो वॉश आउट करता है, जो शिव का रुद्र का स्वरूप है। जनरली हम व्याख्या में कह देते हैं कि शिव जो है विनाश करते हैं, नहीं, जो वीड्स हैं, जो अनवांटेड चीज भी डेवलप हो जाती है, जो हमारे पैसेज में प्रॉब्लम करती है, उसको वो जो है ना क्लीन करते हैं, सो दैट जो ब्रह्म का क्रिएट किया हुआ है, पालन पोषण जो है जो विष्णु का किया हुआ है। यदि आप देखो तो जैसे हम खेत में कुछ फसल लगाते हैं, उसमें वीड्स भी पैदा होती हैं। अब उसको खाद या पानी दो तो वीड्स भी ग्रो करता है, जबकि हमको फसल चाहिए, तो उसको वॉश आउट करना जरूरी है। वो रुद्र का स्वरूप है कि हमारे अंदर जो विकार पैदा हो रहे हैं विद द पैसेज ऑफ डूइंग, वो जो है क्लीन होता है। तो आपको जिंदगी में किसी न किसी रूप में गुरु को प्राप्त करना होगा। बिना उसके जो है साधक साध्य तक जो साधना करता है, उसको पूरा नहीं कर पाएगा। अब इस पूरे वर्कशॉप में मुझे जो लर्निंग हुई, एक वर्ड आया था नॉर्मलाइजेशन। तो फिजिक्स में जो हम नॉर्मलाइजेशन क्वांटम मैकेनिक्स में करते हैं, तो उसमें हम इंटीग्रेट माइनस इंफिनिटी टू प्लस इंफिनिटी, इट हैज टू बी वन। यानी जिस किसी के बारे में हम बात कर रहे हैं वो यूनिवर्स में एग्जिस्ट करता है,
फिर मैं मैथमेटिक्स की वेरियस मॉडलिंग देखा, तो मेरे मन में सवाल आया कि ये डिफरेंट पैरामीटर्स होते हैं, उनकी यूनिट अलग अलग होती है, और उसको नंबर फॉर्म में हम लिखते हैं, तो वो कैसे मतलब जस्टिफाई है, ये क्वेश्चन मेरे माइंड में था। एक लेक्चर में वो क्लियर हुआ कि एस प्लस डिवाइडेड बाई एस प्लस एस माइनस जो कर रहे थे, तो वो डायमेंशनलेस हो जा रहा था। Then it is better to compare, understand. तो normalization in physics मुझे आता था. I learned the normalization in mathematics. दूसरा, I am designated as professor in physics, but I have fascination with mathematics. तो डिसीजन मेकिंग के लेक्चर्स को सुनते हुए मुझे फील हुआ कि आई शुड बिकम प्रोफेसर इन प्रिसीजन इन डिसीजन मेकिंग, कि हाउ प्रिसाइज आई एम। और उसके दौरान मैं फील किया कि ये एटलीस्ट 6th-7th में नहीं तो 9th लेवल पे ये एक कंपल्सरी कोर्स धीरे धीरे इंट्रोड्यूस करना चाहिए, कि जो स्टूडेंट्स कन्वेंशनल तरीके से संस्कार के रूप में सीखते हैं हाउ टू टेक डिसीजन, तो जिस फैमिली या ग्रुप ऑफ फैमिली में एजुकेटेड लोग हैं उन बच्चों को बेटर ही मिल जाता है बाय डिफॉल्ट, लेकिन जो जिस फैमिली में फर्स्ट जनरेशन पढ़ने आ रही है उसके पास तो कुछ होता नहीं है। और इस साल एनईपी में जो मॉडिफाइड आ गया कि फर्स्ट सेमेस्टर में ही आपको मेजर और माइनर डिसाइड करना है, तो जब हम एडमिशन लेने लगे तो बच्चों को बताया कि बेटा अब ये चेंज हो गया है, तो फिजिक्स केमिस्ट्री मैथमेटिक्स में कोई 2 माइनर होगा, 1 मेजर होगा, कोई 1 माइनर होगा, 2 मेजर होगा, तो अब बताओ मैं क्या आपके फॉर्म पे फिल करूं। तो ब्लैंक। वो कहते थे सर अब आप बताओ। मैंने कहा पढ़ना आपको है, कैरियर आपको कब बनाना है। तो मैं हाँ ये जरूर है कि अभी फॉर्म करीब 2 महीने हमारे पास रहेगा, तो बीच में हम चेंज कर सकते हैं, लेकिन नाउ यू हैव टू टेक द डिसीजन। तो मैंने देखा कि वो ब्लैंक हो रहे थे बच्चे। तो जो आने वाले जिस स्ट्रीम में स्पेशलाइजेशन में हम उनको एंट्री करा रहे हैं, उसके पहले कैंडिडेट हमारा इतना प्रिपेयर्ड हो जाए कि टेक द डिसीजन कि किस सब्जेक्ट को हम करना चाहते हैं, क्यों करना चाहते हैं। और वो मुझसे ये जरूर पूछ सकता है, और दैट विल बी इजी, कि सर हम यदि इसको लेके कैरियर बनाते हैं तो इसमें फ्यूचर प्रोस्पेक्ट क्या है, वो हम उसको गाइड कर सकते हैं। लेकिन वहां पे भी वो प्रॉब्लम होती है कि एडमिशन की लाइन लगी होती है। अब एक बच्चे की काउंसलिंग हम यदि उस समय करने लगे तो फिर अब प्रोसेस रुक जाएगा। तो मैं एक्सपेक्ट करता हूं कि एनईपी कोर्स में जब सेकेंडरी हायर सेकेंडरी पे कोर्स को बदला जाए तो डिसीजन मेकिंग को डिफरेंट लेवल पे लिख करके इसको 9th 10th 11th 12th में इंट्रोड्यूस किया जाए। उससे एक फायदा होगा कि जो हम कहते हैं कि दिस ग्रुप इज इंटेलिजेंट, दिस इज नॉट इंटेलिजेंट और लाइक दैट, तो वो गैप जो है फिल हो जाएगा। जैसे हमारा बाकी जो वर्गीकरण है बेसिक यही है ना कि हाँ ये बच्चे जानते हैं, ये अच्छा कर सकते हैं। ऐसा नहीं है कि वो नहीं कर सकते हैं। एक केस में शेयर करूंगा, 2005-6 में तब हम लोग मैनुअल एडमिशन करते थे, तो बच्चे अपना फॉर्म जमा कर देते थे और लिस्ट लग जाती थी। तो एक बच्ची थी, वो मेरे रूम के से ऐसे झांकती थी, फिर हट जाती थी। तो जब तक मैं बिजी था तब तक तो कोई बात नहीं। जब जैसे मैं फ्री हुआ और झांकी तो मैंने देख लिया। मैंने कहा हाँ बेटा बोलो। फिर नहीं, फिर मैं उठ के गया, फिर उसको बुलाया। तो काफी संकोच में थी वो। तो मैंने कहा बोलो, हिंदी में बोलो, अपनी भाषा में बोलो, मुझे समझ आ जाएगा। सर हमारा नाम है लिस्ट में। तो मैंने कहा हाँ नाम है, एडमिशन ले सकते हो। शी वॉज द फर्स्ट जनरेशन ऑफ हर फैमिली टू कम टू कॉलेज लेवल। और गार्जियन भी नहीं थे, क्योंकि वो पढ़े लिखे नहीं थे लोग, तो वो वैसे थोड़ा हेजिटेंसी में पीछे हट गए। फिर मैंने उसकी काउंसलिंग की और मैंने कहा बेटा अपनी भाषा में पढ़ो लिखो, एग्जाम दो, सब कुछ धीरे 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 धीरे, और सेकेंड डिवीजन पास होके गई। जब मार्किंग की बात आई तो उससे जो अच्छे बच्चे थे, तो प्रैक्टिकल में उनको अच्छे नंबर तो मिलेंगे ही, उसको भी अच्छे नंबर मैंने दिया जानबूझ के। तो उन बच्चों ने क्वेश्चन किया कि सर शी वाज नॉट सो इंटेलिजेंट, और प्रैक्टिकल में आपने नंबर उसको भी उतना ही दिया हुआ है, ऐसा क्यों? मैंने कहा कि ये उसको नंबर मैंने नहीं दिया है, ये मेरा इन्वेस्टमेंट है। मुझे पता है कि ये बच्ची जो है कोई इंजीनियरिंग नहीं कर सकती, कोई ऐसा ब्रिज नहीं बनाएगी जो टूट जाएगा। ये एक जनरेशन को इन्वेस्टमेंट मैंने किया है। जब इसकी नेक्स्ट जनरेशन आएगी, उसके माइंड में होगा कि उस समय इस विकट परिस्थिति में, इफ माय मदर हैज परसूड ग्रेजुएशन डिग्री, तो हमारा ये रिस्पॉन्सिबिलिटी है कि कम से कम मुझे ग्रेजुएट होना है। तो वो बच्चे ड्रॉप आउट केस में नहीं जाएंगे, और वहां से वो, क्योंकि जो पीढ़ी होती है ना, जनरेशंस होती है, इट टेक्स डेकेड्स एंड डेकेड्स टू चेंज। तो ये डिसीजन मेकिंग यदि हम 9th 10th 11th में करें तो बहुत चीज बच्चा खुद करके आएगा। तो एक तो हमारा वर्कलोड कम हो जाएगा, और दूसरा हम उसको काउंसलिंग करेंगे तो वो और बेटर एडेड वैल्यू हो जाएगी। तो एक तो मैंने ये सीखा कि ये डिसीजन मेकिंग वाला जो है चैप्टर इंट्रोड्यूस करना चाहिए, क्योंकि एवरी मोमेंट वी आर गोइंग टू डिसाइड, एंड डिसाइड फॉर व्हाट। दूसरा मुझे लगा कि ये जो आर्टिफिशियल इंटेलिजेंस है, और इसमें हम साइबर सिक्योरिटी की बात कर रहे हैं, यदि कुछ ऐसा प्रोग्रामिंग हम मतलब डिजाइन करें कि जैसे कंप्यूटर स्क्रीन पे हम कुछ कर रहे हैं, तो वो जो है ना हमारी फेस रीडिंग ऑटोमेटिक करना शुरू कर दे। और जैसे नेचुरल इंटेलिजेंस में आपकी फेस रीडिंग से हम सैडनेस, हैप्पीनेस, स्मार्टनेस, कुछ मन में गड़बड़ है वो भी मुझे जो है आभास हो जाता है। तो यदि ये कंप्यूटर रीड करके प्रोसेस करे, तो जो आप उसको इंस्ट्रक्शन दे रहे हैं उसको वो फिगर आउट कर सकता है कि समथिंग मॉडिफाइड, एंड व्हाई नॉट टू होल्ड इट। दैट आई वांट टू से इंटेंशन रीडिंग। नेचुरल इंटेलिजेंस जो है वो ठीक है कि हम नहीं पढ़ते हैं, इग्नोर कर देते हैं, दे देते हैं, लेकिन नेचुरल इंटेलिजेंस इज पावरफुल टू रीड द इंटेंशन फ्रॉम द फेस। तो क्या उसमें हम कुछ ऐसा करें कि वो हमारे इंटेंशन को पढ़ना शुरू कर दे, आइदर आई वांट और नॉट। स्क्रीन खोलते ही जो है, तो साइबर सिक्योरिटी में जो है ये हेल्प कर सकती है। हाँ 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 हाँ, नॉट गुड। तो मतलब यदि इस तरह से, दूसरा एक स्पिरिचुअल डायमेंशन है जो तुलसीदास जी ने लिखा है, कर्म प्रधान विश्व करि राखा, जो जस करनी तस फल चाखा, यानी सबसे ऊपर कर्म है और आज का कर्म हमारा कल का भाग्य है। कर्म बेसिकली स्क्रिप्ट आप लिख रहे हो, आइदर फॉर सेल्फ और फॉर अदर्स, और वो अपने ज्ञानेंद्रियों से कर रहे हैं या मानस से कर रहे हैं, मन से सोच के कुछ कर रहे हैं, वो भी इंस्क्रिप्शन हो रहा है। अच्छा, इसका एक बेसिक कैरेक्टरिस्टिक है कि जो क्रिएटर है, कर्म जो करता है, वो उसके साथ इंस्क्रिप्शन उसकी होती है। तो जो हमारे बॉडी, आवर बॉडी इज हैविंग नियरली 50 ट्रिलियन cells. Every cell is made up of so many atoms. और एटम्स के बीच